So let's talk about mechanical advantage and efficiency. So what is mechanical advantage? It's going to be the number of times a machine multiplies the effort force, or the amount of force that you have to put into a simple machine. And this is how you're going to calculate mechanical advantage. It's going to be mechanical advantage equals F out over F in. Now your F out is going to mean the amount of force that the machine does. And if the machine is lifting something, this could be weight. And the F in is going to be the amount of force the person has to do. So let's do a sample problem. Keisha applied 20 newtons of force to turn an ice cream freezer crank. The crank then applies a force of 60 newtons. What is the mechanical advantage of the crank? So the hardest part about these problems is figuring out which one is which. So remember, in is what you do, the person, and out is what the machine does. So Keisha applied 200 newtons of force, so that is going to be the amount of force of input. And then the crank applies 60 newtons of force, which means that is going to be the out force, what the machine does. We are going to try to find mechanical advantage here. The equation is force out over force in, which would be 60 over 20, which would make it a mechanical advantage of 3. Notice I don't have units here, and that's because both of our data is measured in newtons, and when we divide them, they're going to cancel out. So a mechanical advantage does not have a unit. Let's talk about efficiency now. So efficiency is going to be work out divided by work in times 100. So work out means how much work the machine does, just like force out. And work in means how much work the person has to do. Here's an example of an efficiency problem. So, a heat engine takes in 9,000 joules of heat from a high temperature reservoir and produces 3,000 joules of work in each cycle. What is the efficiency? So again, the hardest part about these is trying to figure out which one is which. So remember, in is always the person and out is the machine. In this particular example, there isn't really a person, but 900 joules of heat are taken in, so that is our work in, and the engine is going to produce 300 joules, so that's the work out. Our efficiency is what we're looking for. Our efficiency is going to be out over in again times 100. And so we're going to have 300 divided by 900 this time times 100. So our efficiency for this machine is 33%. Now, for efficiency, the units are always going to be percent.